Okay, so in this first video, I'm going to go over the midterm review part 1, which is over the first 6 weeks covering solving equations and inequalities. In translating an expression, you want to be careful in the words that are being used because they're going to tell you where the operations go. So in this first statement, we see the difference. Difference means subtraction. So we know we're going to need to subtract. And the word difference is one of those special words. You have difference, sum, quotient, and product. And those always mean that that operation is going to go in place of the word and. So this subtraction is going to go in the place of the and because the word difference was used. Of 3 times a number, so here we know that we're getting 3 and we are multiplying it by some number that we don't know, so that's going to be a variable. And 7 is our equal sign. 10 less than the number. Less than is another special phrase where you're subtracting, but it's going to be 10 less than what's ever after it. So this 10 and the phrase and number are going to swap sides because you're going to take 10 from whatever number is being represented by the variable n. So in putting all this together, coming back and reading, we're not going to start with the subtraction sign. We're going to start with the 3 times n, which we can write as 3n. Then we're going to go ahead and put in that minus, and then we have that next word 7 is our equal sign, and then we have the 10 less than the number. So once again, instead of putting 10 first, I'm going to put that same variable n, subtract 10. In this next problem, we are needing to solve for the variable a. So as mentioned in class, different routes that you can take. The path that I'm going to take is drawing my line through the equal sign to remind me whatever I do on one side of the equal sign I have to do on the other. But then I'm also going to go back and say, okay, well, what variable are we solving for? Because sometimes you get equations that have multiple variables versus just one. So in this one, we're solving for the letter A. So I'm going to go ahead and put my A off to the side. This is what I want to end up with the A all by itself. In reading this equation, we are starting off with A being multiplied by a -2. So this is going to be, we're timesing by a -2. After the A is being multiplied by a -2, we are subtracting 2. And then the entire numerator is being divided by 3. So the last step would be dividing by 3. So we're reading this as -2 times A minus 2, all divided by 3 equals 6. So I've written the steps off to the side here in reverse order. Now to actually solve, we're going to start from the bottom, working our way back up to get the A by itself, and we're going to do that using inverse operations. So the first thing that we're going to do is eliminate that 3. So instead of dividing by 3, the inverse is going to be to multiply by 3. And that's going to cancel the 3 out. So I'm going to go ahead and multiply the left side by 3 and the right side by 3. That's going to leave us with the numerator -2a minus 2 equals 18. and these 3's have canceled out. This step has been undone. The next part's going to be to get rid of that -2, the -2, and to do that we're going to use inverse. So instead of a minus, we have a plus, and then whatever we do on one side, we have to go back and do to the other side. This is going to make the 2's on the left cancel out, leaving you with -2a equals 20. This step is now gone, and then we're left with our final step. Instead of multiplying by a -2, we're going to need to go and divide. Everything gets divided by a -2. That makes the -2's here cancel out, leaving you with a equals -10. Last step is done, and we can see that we are left with our final answer of a equaling -10. And then you can always go back and check by plugging your answer of -10 into the original problem. So, and this is also a good test taking strategy because you have your calculator to use when you're taking your test. So you can do -2. Instead of times a, I'm going to put in my answer of -10 minus 2. All of this is going to be divided by 3, and we're going to see if that equals 6. If you're using your calculator, you can type this whole thing in. So here we have -2 times -10 comes out to +20. +20 minus 2 divided by 3. 20 minus 2 is 18, and then 18 divided by 3 gives us that 6. So here we can see that it is indeed correct. So on this problem, once again, we're solving an equation. So I'm going to draw my line through the equal sign to remind us whatever we do on one side, we have to do to the other. The next thing you want to do is go ahead and identify the variable which we're being solved for, and the directions we're being asked to solve for the variable x. X is located right there. And so when you read this, we read it as x divided by 3 plus 5 equals -2. So when you're going to solve, remember you're going to undo the process. So here we're having x is what we want alone. X was being divided by 3, and then 5 was being added, which gives us a result of -2. So inverse, instead of a +5, is going to be -5 on both sides. When we do that, the 5's on the left are going to cancel out, leaving you with just a fraction of x over 3 equals -7. The next step is, instead of dividing by 3, inverse is going to be to multiply. So we're going to multiply the left by 3 and the right by 3. When we do that, the 3's on the left are canceled out. That leaves us with x equals -21. Once again, it's a good idea to go back and check. So I'll use this area here to show my work in checking. We're going to take our answer choice of -21 and put it in place of x. Now, being that your test is multiple choice and that you have access to a calculator, you can always work backwards from those answer choices. So instead of x, -21 divided by 3 plus 5 should equal -2. -21 divided by 3 gives you -7 plus 5 equals -2. And then combining the -7 and 5 is -2. And you can see -2 equals -2. This is true, which means our answer here is correct. Here we have another equation in which we're solving. So same process, I'm going to go ahead and draw my line through the equal sign. Now this one we can actually solve two different ways. I have a lot of students who want to take care of those parentheses first, and so they're going to go ahead and take that step of distributing. So I will go ahead and do that as well. It's distributing the 6 to the x as well as to the 2. And that gives us 6x plus 12 minus 4, because that minus 4 is not in the parentheses, so it's going to stay as is and equals negative 10. Now before I set up my column to work backwards, I'm going to go ahead and combine my like terms. So the 12 and the negative 4 need to be combined, and that's going to come out to a positive 8. And then we have the 6x still in the front, and it's still equal to negative 10. Now from here I can go ahead and solve the way I did previously. Identify my variable, x. X is being multiplied by 6, and then we're adding 8, and that's where our negative 10 comes from. So I'm working backwards. It's going to be minus first, so subtracting 8 from both sides. And then the 8's are going to cancel out, leaving us with 6x equals negative 18. And then the next step is going to be to divide both sides by 6, and that's going to come out to x equals negative 3. And then once again, you can always go back and check. So if I check, this is going to be 6 times, instead of x, negative 3 plus 2 minus 4 should come out to a negative 10. And then here, following PEMDAS, negative 3 plus 2 goes first, so that becomes a negative 1. So 6 times negative 1 minus 4 equals negative 10. So negative 10. And then 6 times negative 1 is negative 6. Minus 4 should equal negative 10. And then when you combine, you do get negative 10 equals negative 10. So I mentioned we could solve this another way. I'm going to go ahead and show that second way right now. Once again, I'm still going to draw my equal sign, my line through my equal sign. And then because I only see the variable displayed one time, I can go and say I'm solving for x. That's what we were told to do, or being asked to do. I'm going to go and put my x off to the side. Looking at this in terms of x, the very first thing that's happening to the x is that we're adding 2. After the 2 has been added, it's being multiplied by the 6. And then from there, we're subtracting 4. X is being added by 2. It's in the parentheses, so we do that first, order of operations. Then after the parentheses, it's going to be multiplication or division. We're multiplying by the 6, and then you add or subtract. So that's why this is in the order that it's in. And then from here, if we're at the bottom, we got to go back up to get the x isolated to find what it's equal to. Starting at the minus 4, inverse is going to be plus 4. So I'm going to add 4 to both sides. That's going to leave us with 6 times the sum of x and 2 equals negative 6. The next step is, instead of multiplying by 6, we are going to divide by 6. So everything gets divided by 6. These are going to cancel out, leaving us just with the x plus 2 is equal now to a negative 1. And then we're at our last last step, instead of plus 2, it's going to be a minus 2. So we're subtracting 2 from both sides. The 2's on the left are going to cancel out, leaving us with x equals negative 3, which is the same answer we got previously. So once again, different ways to go about solving these equations. So when we're solving this equation, notice how the variable that we're being asked to solve is written multiple times. So before you do anything, you have to get those all together. If they're on the same side, such as the 8x and the 2x, then you're going to combine those together. That's going to give us our 10x. Everything else is going to remain the same. Now, since the 15x and the 10x are on opposite sides, in order for them to be on the same side, one of these terms has to change, and we change it by using the inverse operations. Because I'm going to want to get the x variable all by itself, I'm going to choose to move the 10x instead of the 15x. That way I can have all my x's on the left and all my constants on the right. So in order to do that, the inverse of a positive 10 is a negative 10x. This 15x minus 10x is 5x. These are gone because 10x minus 10x is 0. And I'm left with a positive 10 on the right. And then from here, it's a one-step equation. To get the x isolated, we're going to divide both sides by 5. And that's going to leave us with x equals 2. And then you could check it as well. If you check it, this 2 is going to go in place of every x. So instead of 15x, if I check it here, we would have 30, because 15 times 2 is 30, equals 8 times 2 is 16, plus 2 times 2, which is 4, plus 10. Then we got to combine our constants here on the right. 16 plus 4 comes out to 20. Still got to add that 10. And then that leaves us with 30 equals 20 plus 10 is 30 as well. So we are left with a true statement, which means this is correct. So here is another equation that we're being asked to solve for x. And then just like the previous problem, we see x is on the left as well as on the right. So before we do anything, we want to go ahead and get those together. I'm going to go ahead and choose to move the 5x because it's smaller, plus it also keeps me with my variables on the left, which is a good habit for proper notation. So because of the plus sign in front of the 5x, I know the 5x is positive, so the inverse is going to be to subtract. Remember, even though they are like terms, because they are on opposite sides of this equal sign, we have to use inverse operations. They are not in agreement with each other as far as the sides go, so one of them has to change, which is why we're using that inverse operation. When we do that, 9x minus 5x gives us a 4x. The negative 19 is going to stay. The equals will stay. The 21 will stay. And your 5x's are gone because 5x minus 5x cancels out to 0. Next step is to add the 19 to both sides because that is the inverse of the negative. And then when you do that, the 19s are going to cancel out, leaving you with just the 4x equals, and this becomes 40. And then your last step is going to be to divide everything by the 4, and that leaves us with the x variable by itself, the 4 is canceled out. And 40 divided by 4 is 10. Once again, good habit to check. This 10 would go in place of both the x variables. So if I'm checking, instead of 9 times x, it's going to be 9 times 10 minus 19 equals 21 plus 5 times 10. 9 times 10 gives us 90. 90 minus 19 should equal 21 plus 5 times 10 would be 50. 19 taken from 90 is going to be 71, which equals 21 plus 50 is also 71. So this is a true statement, which means our answer here of 10 is correct. So this one here, number 7 of the review, is a little tricky, and you have your variables on both sides, which means you have to get them together, and it also has the 4 that needs to be distributed. Now, I don't want to start off and do my work backwards yet because I got to get my variables on the same side. So our first step here is going to leave the left side alone for the time being. Leave it with 28 minus 7x. But we're going to set it equal to negative 4 times negative 7x, which is a positive 28x. And then negative 4 times negative 7 is a positive 28. The next step is going to be to get our variables on the same side. Once again, it doesn't matter if you move the negative 7x or the positive 28x. What matters is that you are using that inverse operation. If you choose to move the negative 7x, you're going to do that by adding 7x to both sides. If you choose to move the 28x, you're going to do that by subtracting 28 from both sides. They are on opposite sides. To move them, you have to use that inverse operation. Okay, I'm going to go ahead and opt to move the 28x. And so once again, as I mentioned a moment ago, the way I do that is by subtracting 28x from both sides. Inverse operation. When we do that, this 28 here, where we start off, stays the same. So that's still there. Negative 7x minus 28x becomes a negative 35x equals, these have canceled out, 28x minus 28x is 0, but the 28 over here at the end without the variable remains. Our next step is going to be to isolate our negative 35x. To do that, we need to get rid of this positive 28. So once again, the inverse would be to subtract 28 from both sides. When we do that, the 28's on the left canceled out because 28 minus 28 is 0, leaving us with negative 35x equals 28 minus 28 is 0. We do have a solution here. The x variable is present, which means you have a solution. There is only one number that you can put in place of x that will make this equal 0. And so your last step is going to be to divide everything by negative 35. And when you do that, the negative 35's on the left cancel out, leaving you with x. And then 0 divided by anything is 0. Once again, you come back and check. if x has a value of 0 and anything times 0 is 0, when you take your 28 minus 7x equals negative 4 times negative 7x minus 7. If we put 0 in place of the x, this is going to go away and this is going to go away because anything times 0 is 0. So we're looking at 28 equals negative 4 times negative 7. 28 is already by its reduced on the left. And then negative 4 times negative 7 is a positive 28. Okay, our next problem in solving the equation. Once again, we do have the parentheses, and we have the variable that we're being asked to solve is present both on the left and on the right. So before we do anything, we have to get those together. We have to get them on the same side. I cannot move this one on the right just yet because it's in the parentheses, which means we have to go ahead and distribute that first. So this is going to be 2 times 4y and then 2 times 7. 2 times 4y leaves us with 8y, and then 2 times 7 is 14. Everything on the left is going to come back down. Now, if you take a moment and you read what you have here, we have 8y plus 14 equals 8y plus 14. Whenever you have something equal itself, or this right here, we're looking at an identity. If you don't see that, it's okay. We can still go ahead and proceed in solving this equation. So I'm going to go ahead and get the variables on the same side. So I'm going to subtract 8y from both sides. Now, 8y minus 8y is 0. Those are gone, leaving us with 14 on the left. And on the right, 8y minus 8y cancels out, leaving us with 14. Our variables are gone. There's nothing left to solve for, so we look at what is our ending statement, which is 14 equals 14, and this is a true statement. When you have an identity, you're left with something equals itself, which is true, and when you have this, your answer is going to be all real numbers, because whatever number you put in place of x from negative infinity to positive infinity, you will always get a true statement. You will always have the left side equal to the right side. So on question number 9, we're being told that Lewis drew a floor plan for his garage, which is shown below. If the perimeter of the garage is 92 feet, we're asked to solve for x. Couple things here. Perimeter means you're adding up all the sides.
Interesting.
A rectangle, as we see here, has the sides, which are congruent, and the top and bottom, which are congruent. So when you're doing your perimeter, the formula is going to be 2 times whatever the length is plus 2 times whatever the width is. And then from here, we're going to substitute in what we know. So we know that that perimeter is 92 feet. So instead of P, we're going to put 92. And then it is still equal to 2. Our length, we have 3x plus 5. And then we're going to do 2 times our width, which we have as 2x plus 1. Now, is this the only way that you could have done this? Not at all. You could have said, okay, if the top here is 3x plus 5, the bottom is 3x plus 5. If the side has a length of 2x plus 1, then this is also 2x plus 1. And then you could go around and combine all your like terms. And the way I have the problem set up, that's not the path that I took. That doesn't mean that I'm wrong. It just means, once again, we can solve these different ways. So from here, I'm going to go ahead and distribute. My 92 is going to stay as is for the moment. 2 is going to be multiplied to everything inside the parentheses, starting with the 3x, which gives us 6x. And then 2 times 5 is 10. Then we got to do the same thing for the second half. 2 times 2x is 4x. And then 2 times 1 is 2. So here it looks long. We have a lot of terms that we can combine, though. We have a 6x and a 4x, which together makes 10x. We also have a 10 and a 2, which when we combine them gives us 12. And then this is still equal to our 92 from the left side. So my diagram here got in the way. So this 92 still stays, my equal still stays, and then here I have the 6x and 4x combined to give 10x, 10 and 2 combined to give 12. And then I'm going to go ahead and proceed in solving. So this is x is being multiplied by 10 and then adding 12. So in working backwards, because we multiply by 10 and then add 12, got to start off by getting rid of the 12. Instead of a plus 12, it's going to be a minus 12. When we do that, 92 minus 12 is 80. 80 is equal to 10x. And then our last step would be to divide both sides by 10. And when we do that, we are left with 80 divided by 10 is 8. So we get 8, and 10 over 10, that cancels out to x. So we have x equals 8. And then same thing, you could go ahead and solve, or not solve, but check by plugging that 8 into the x, adding them all up, and you should get 92. So here in question 10, we're being told that the triangle has a perimeter of 41 yards. What is the length of the shortest side? So perimeter, once again, is adding up all the sides. But instead of just solving for x, we have to go back and answer what is the length of the shortest side. So we're going to solve for x and then substitute it back in to see what each side comes out to. When we're looking at our picture, we notice that we have 2x plus 3, x plus 10, 5x minus 4. We have to combine all of our like terms and set it equal to 41. So we have 2x, which can be combined with x, which can be combined with the 5x. 3 is a constant, which will be combined with 10, and the minus 4. 2x plus x. Remember, if you don't see a number in front of the variable, you can say there is a 1. So 2x plus 1x gives us 3x. And 3x plus 5x is 8x. Next, we have 3 plus 10, which is 13, minus 4 is 9. So this is going to be plus 9. And then it's going to be equal to 41 because that is our perimeter from the problem. Okay, so we have our equation. We're going to go ahead and solve by using inverse operations. The first step is going to be to eliminate the 9 because this is x times 8 plus 9 is 41. So starting with the 9, subtract 9 from both sides. And when we do that, the 9's on the left cancel out, leaving us just with 8x is equal to 41 minus 9 is 32. Our next step is going to be to divide by 8. Everything gets divided by 8. And when we do that on the left, the 8's are going to cancel out, leaving us just with the x equals, and then 32 divided by 8 is 4. So once again, we're not done because this is x, but we're being asked to find the length of the shortest side. So which means we're going to have to put 4 in place of x. So this is going to be 2 times 4 plus 3. 2 times 4 gives us 8, and 8 plus 3 is 11. So here we have a side length of 11. 4 in place of this x, so this would be 4 plus 10, which is 14. And then our last one, we have 4 in place of x here, so it's going to be 5 times 4 minus 4. 5 times 4 is 20, and 20 minus 4 comes out to 16. So we're looking at 11, 14, and 16. The shortest side is that 11. So the shortest side is 11 yards. So here we're solving this equation for y, and looking at it, it has only variables. There are no numbers here. We can still solve it, but our answer is going to be in terms of variables. And second, this is an equation in standard form if you're comparing it with the linear functions. Just because we're getting the y on its own does not mean that this equals y equals mx plus b. When you're solving for y here, the letters that you see will also be in your answer. So I'm going to go back to, in solving, put my line through the equal sign. We're solving for y, so here's my y variable that we're being asked for, and I'm going to go and say, okay, what is going on with this y? We start with the y. The very first thing that's happening is the y is being multiplied by the b. So off to the side, I have, this is y is what we're solving for. Y is being multiplied by the b. After the y gets multiplied by the b, we are adding an ax. Now this ax is positive, so a positive ax is being combined with a by. So that's going to be the next thing that I write off to the side. And then from there, we're going to get our value of c. So I have my setup. starting from the bottom and working our way back up to get the y variable by itself. We're going to do this by using our inverse operations. So instead of a plus ax, it's going to be minus ax. The variables ax on the left cancel out. The by will remain. And then here, c minus ax, those are not like terms because they are not the same letter. So all I can do is write them out right next to each other. And then our last step is going to be, instead of multiplying by b, we have to go back and divide by b. So both sides will be divided by b. The b's on the left are going to cancel out, leaving us with y equals. And then because we are left with different variables, I cannot reduce anything. So my final answer is going to be y equals c minus ax divided by b. And this is our final answer. So on this one, we're being asked to solve for b. I'm going to go ahead and put my line through the equal sign. I'm going to find where b is. Here I see it's in the numerator. And then I'm going to go ahead and say, okay, b is what we want. That's what we're being asked for. So b is being multiplied by h. And after b is multiplied by h, it is being divided by 3. And that's how we get the value of v. So in solving inverse, instead of dividing by 3, we're going to multiply both sides by 3. And when we do that, we're left with 3v on the left equals, on the right, our 3's have canceled out, leaving us with the bh. So this one has been done. Our next step is to eliminate the h. So instead of multiplying by h, we are going to divide. Both sides get divided by h. Now, on the left, since I have different variables, I don't know what they are, I cannot reduce. I cannot do anything more with what's on the left. So when I write it, I'm going to write it as 3v divided by h equals, and then on the right side, the h's have canceled out, leaving us just with our capital B. So we have v equals 3v divided by h, and that's going to be our final answer. So on this problem, we're being asked to graph the solutions of 4m is less than 8. In order for us to graph these solutions, we have to get this m isolated. So we're going to be solving an equation. We're solving for m. We want the m by itself. And then to graph, we're going to graph on a number line, not a coordinate plane. So here, our first step, here's m. M right now is being multiplied by 4. So the inverse is going to be to divide by 4. Both sides get divided by 4. 4m divided by 4, the 4's are going to cancel out, leaving us just with m is less than negative 2. I did not need to reverse the inequality symbol because we are dividing by a positive 4. Positive 4. Then I'm going to go ahead and graph the solutions on a number line. So here is a number line. I'm going to go ahead and put this is my 0, negative 1. Here's my negative 2. So at the negative 2, I'm going to go ahead and draw an open circle because This is just the less than, not less than or equal to. And then from there, because we want all the numbers less than -2, I'm going to shade to the left. So M is being represented by this number line. Okay, so once again, we're asked to solve. We have an inequality, which is very similar to an equation. We're being asked to solve for x. So here we see x is only there once. We are multiplying by a -2, and we are then subtracting 2 to give us the value of 8. So the inverse is going to be to add 2 to both sides. When we do that, we're left with -2x. These are gone. It's less than or equal to 10. Our next step is going to be to divide. Now here we are dividing by a -2. So we want to make sure that we don't forget that. So I'm going to divide the left side by -2 and the right side by -2. The -2's on the left cancel out, leaving us just with the x, and on the right we're left with a -5. Now, since we divided by a negative, we're going to have to reverse the inequality symbol. That is your rule. Anytime you multiply or divide by a negative, you reverse the symbol. Okay, we're solving inequality again. Once again, you can solve these equations or inequalities several different ways. This is just one example. So here, I have 5 plus 2m is less than or equal to 3m. Because I have variables on both sides, and to solve, the variable needs to be just on one side, I'm going to choose to move this to m. And I'm moving it because it's the smaller number. So here is -2m on both sides. When I do that, that leaves us with 5 on the left is less than or equal to, because the 2m's canceled out, m. Here, the m is already isolated, so I don't need to solve any further. But the variable is on the right, and typically when we write our answers, we want that variable on the left and the constant on the right. So then that begs to question, is this going to change as well? And the answer is yes. If you flip what was in front and after around, then you got to flip the symbol around as well. So in this case, even though we did not multiply or divide by a negative, we still reversed the symbol because we went and we switched what was before and after. We switched that constant in the variable. Okay, so notice here, right now, m is bigger. M is still bigger. 5 is smaller because it's 5 is less than or equal to m. And 5 is still less than or equal to the m if you read it backwards. So in this one, it's asking us to state the solutions and also to include any restrictions. Jenny sold 7 cookbooks and she needs to sell at least 12 cookbooks to earn a prize. So it's not saying she needs to earn exactly 12. It's saying she can sell however many she wants, X. And she's already sold 7. Whatever she sells needs to be at least 12 if she wants that prize. At least means this is the minimum amount. So it's going to be 12 or more. What she sells has to be greater than or equal to 12. When you solve this, we're left with x is greater than or equal to 5. So Jenny needs to sell at least 5 cookbooks. When you have your inequality symbol, inequalities means every single number including decimals. But Jenny cannot sell part of a cookbook. So when it's asking for those restrictions, we're going to go ahead and cap or state whole, no fractions, no decimals. So whole numbers only. So she can sell 5 or more whole numbers only, entire cookbooks only. Okay, here again we're solving an inequality. The 2 is going to need to be distributed. And once again, this is just one way to go about it. So this would be 2 times a, and then 2 times -1 is a -2. Everything else is going to remain the same. Our next step is going to be to combine our like terms here. And that comes out to 10. Positive 10. The 2a in the beginning still stays and is still greater than or equal to 12. Our next step is going to be to subtract 10 from both sides. When we do that, the 10s are going to cancel out because we use inverse operation. 2a is greater than or equal to 2. Last step is going to be to divide both sides by 2. And we get a is greater than or equal to 1 as our final answer. Okay, so here we're solving this inequality for the variable r. And you'll see r is in the -6r plus 4r and the -2r. So here we need to go ahead and combine those like terms together. -6r plus 4r, they're on the same side, so I'm just going to bring them together, creating a -2r. My 4 at the beginning is going to stay. It's still less than or equal to -2r minus 7. The next step is going to be to go ahead and get the variables together. So I'm going to go ahead and move this -2r to the other side. If it's a -2r, the inverse is going to be to add 2r to both sides. When we do that, we have our 4. -2r plus 2r cancels out, leaving us just with our less than or equal to symbol on the left. On the right, -2r plus r cancels out, leaving us with our -7. So when we're reading this, we see 4 is less than or equal to -7. This is a false statement, also known as a contradiction. When this happens, when you're left with a false statement, something that's contradicting itself, your answer is going to be no solution. There is no number that you can put in place of r that will give you a true statement. So here, it's saying Amber decided she would spend no more than $120 to buy a jacket and a skirt. It says the price of the jacket was 20 more than 3 times the price of the skirt. And then we're being asked to state the solutions and include any restrictions. So this problem has a lot. We know that she's going to purchase a jacket along with a skirt. And then she wants to spend no more than 120, which means whatever, this is what she's buying. What she's buying cannot be greater than 120. It has to be less than or equal. So it's the less than or equal inequality symbol and the 120. In the statement, it's telling us that this jacket is 20 more than 3 times the price of the skirt. But it doesn't tell us anything about the price of the skirt. So I'm going to go ahead and let that skirt be represented by K. The jacket is going to be 20 more than 3 times the price of that skirt. So 3 times the price of the skirt plus an additional 20 is what's being represented by the jacket. But we also got to add this actual skirt that she's going to purchase, and that still needs to be less than or equal to 120. So we have 3K plus K is 4K plus 20 has to be less than or equal than 120. We're going to subtract 20 from both sides, and that's going to leave us with 4K is less than or equal to 100. Then our last step is going to be to divide by 4. And we're left with K is less than or equal to 25. So the price of her skirt has to be less than $25. But we're not going to do all the values less than 25 or equal to. So the skirt is less than or equal to 25, but we don't want to include negatives, because negatives are -2, 3, -12. Those are all values less than $25, but you can't go and buy an item for a negative amount. And then decimals are okay because in money we have our decimals.